Hi, I'm Lauren White. In this lesson, we'll talk together about how to rank electrophile strength by analyzing the density of positive charge. So when we think about organic reactions and how quickly they occur, we need to think about how strong our electrophile is. And the first thing we want to consider here is how the positive charge is distributed about our electrophilic atom. The strength of an electrophile just tells us how fast it's going to react with a nucleophile. Faster reaction means stronger electrophile. Also remember when you're ranking electrophile strength that any molecule with a full or partial positive charge could be an electrophilic atom. So let's do some examples. Here we need to find the stronger electrophile in the following pairs. So let's start with A. On the first molecule we've got that big old positive charge. So it's for sure an electrophile. And the second molecule has a carbon connected to a chlorine. So not fully positive, but that chlorine will definitely hog some electrons, making that carbon feel a little exposed, a little positive. Which one is stronger? Well, remember that nucleophiles are electron dense, so they'll be pretty negative. Which of these would make the nucleophile more attracted to it? Well, the one that's more positive, right? Positive and negative attract. So the molecule on the left is a stronger electrophile. Let's take a look at B now. The first thing you should notice is that there are no full positive charges here. So neither one of these would be as strong as the one we found in part A. But let's see which of these two is stronger. So in both cases, we have a carbon bound to an electronegative atom, oxygen in this case. So how do we decide which one will be better then? Well, what's the big difference between these two molecules? That double bond. So how would a double bond affect the ability of electronegative oxygen to hog up the electrons from the carbon? It would make it better at it. In fact, you can think about the single bond on the right being like a typical city street, but the double bond is like a big multiple lane interstate for electrons. Oxygen double bonded will be able to pull more electron density towards it and make the carbonyl carbon feel even more positive than if it were just singly bonded to that oxygen. Remember, these are just the symbols we use to show partial positive charges. So here, the molecule on the left is the stronger electrophile. Finally, let's look at part C. Again, we have nearly the same molecule, but what's different between them? Oxygen versus nitrogen. So what are some differences between oxygen and nitrogen that come into your mind? Hopefully one of the first things you think of is a difference in electronegativity. Remember, the periodic trend of electronegativity tells us that oxygen is more electronegative than nitrogen. So oxygen is going to pull electrons towards it just a little bit more than nitrogen would. So the carbon on both molecules is going to be feeling positive, but the one with the oxygen hogging electrons would be just a bit more positive. And because of this, our molecule on the left with oxygen would be the stronger electrophile. Now, you should feel more comfortable ranking electrophile strength by looking at how much positive charge is present on the electrophilic atom.